Okay, at this stage we're going to create the silver layer, and in the silver layer what we're going to do is we're going to create 4 tables. Let's lay out these tables. Let's design these tables first, then before we move on to the coding aspect of these tables, and then we see how we can structure this. So we've successfully created the bronze. Now we're in the silver. So let's create a new design over here and name this silver. Now let's go back to the previous tables that we had. So we had the orders table, right, which has this column. But this time around what we're going to do is, when we go back to the table, when we look at the data, we realize that the data had some flaws, right? So in this orders table, what we're going to do is we're going to create another orders table in the silver layer, but this time around we're going to clean. The first table is going to be a cleaned table, right? The first table is going to be a clean table which will contain every like a standardized table, which will have duplicates removed, which will have every error removed, every data misrepresentation removed, and so on. So with this, what we're going to do is we're going to call this table silver, let's say orders enriched, right? So this is going to be the clean table. So this is going to be cleaned table, right? So at this point you clean the table, you removed every duplicate and every thing that you had. So it's going to carry that column plus the extra columns that we had, the ingest and source file. So we add 2 new, that's ingest, and we had source file. So ingest is timestamp, right? But this time around it's a clean table. That's what we're going to do. Clean table. The reason why we're designing this is for you to get a good understanding, visual understanding of what we're creating. This is for beginners to understand how to recreate architecture and so on, right? So this is for beginners to know, right? So first you need to visualize the architecture, visualize the table, then you go into the actual coding aspect itself, right? With that, you know what you are building, you have a good representation of what you are building, right? So this is a clean table. This will be the first table that we have, right, which will be a clean state. Then we have we'll code another table, right? But this time around this is not going to be a cleaned one. This is going to be quarantined orders, right? So this quarantined orders, so we call this table orders quarantine, right? Orders quarantine enriched. So this table is going to carry every anomaly that we realized in the original bronze table, right? In the original bronze table, which is over here, anomalies that we found in the orders table, that is what is going to be in the quarantine orders table, right? Then what we'll have another table which is going to be for the customers clean table, right? So if we go back to our diagram, we have this customers table, right? So we bring it in here, we can bring it in here this way. So this is going to be our customers table enriched. Right, if we go back to the table, you can see we also have ingested at and source file. So we can add this. So we have ingested at source file. So this customers enrich table is just going to be a cleaned customers table. And if we look at the data from the bronze, it also had some errors in the tables, right? So we're going to clean those, remove duplicates, remove every clean thing, and then this table should be clean and well structured, meeting the standard that we want it to meet. So at this point, this is where you are doing your transformation. This is what we call transformation. This is where you're going to do the actual transformation. Transformation simply means you're going to clean unnecessary things. You're going to join. You're going to make enrichment. You're going to add things. You're going to meet the standard that the end users want, right? So this is where we enrich it. Enrichment is just means you're adding things, removing some things, making it standardized, and that whole process of doing all the cleaning, the joining and all that, that's what they call transformation. You are changing the nature, the original structure of it to suit some structure that individuals or your end users want. So we have this. Then we're going to create a fourth table. We're going to create a fourth table, which will be the final table that we will have, right? A fourth table which is going to be orders. We had orders enriched, right? So we had orders. We're going to call it orders customers enriched. So what is this table going to be? Well, this table, what it's going to contain is, if you take a look at this has orders enriched, right? So this is going to be, we're going to change this orders plus customers, right? Orders plus customers. So over here, this is a new table we're going to create, and this table is going to have an enriched state, which will be every detail of orders, plus we already know you have customers ID, plus we're going to add details of these customers in this table, right? We're going to add details of these customers in this table. So we could add the name, customer name, right? So we could say customer name here, and then we have customer email, which will be attached to the orders that they made. So for every order that was made, you need to find the customer's detail, that specific customer who made this order, and then we create out of this, we join, and then we make this new table, which will give us the full scope of orders, the orders, every detail about an order that happened, the customer's name, the customer's email, the customer's city as well, right? We don't need the last one, so we have this as string, this as varchar, and this as string. Yeah, so these are the tables we're going to create in the silver layer, right? So these tables are going to be our process tables, right? You're going to, over here, orders enrich, which will be a clean table of orders, removing duplicates, removing errors, nulls, and so on, removing all that and making it a clean stated orders table which conforms to the standard that we want, right? It should meet some standard. There shouldn't be lagging spaces between the names and all that. It should be trimmed, it should be clean, This is the orders for orders table. Over here, quarantine orders, which is going to pick data that failed to meet the orders standard that we want. We'll quarantine those orders here. We'll keep them here so that in future, those are like outliers, right? So that in future, when we want to reference that or we want to make use of that, we still have this table ready. And anyone who needs it to look at outliers, when you get access to the table, you know that these are outliers that the person want to make use of, right? And then we have customers cleaned. So this table, we are going to take out duplicate. We're going to move every blank and so on and clean this customers table. And that was going to be the customers enriched. Then we have the orders plus customers table. This table is going to be more like a join between the orders and the customers table, where we find the specific customers detail who placed those orders or made those orders, and then we join them, and then we see, and we either make, if the order was completed or something, we could also make those analogies as well. So these are the tables that we're going to create in the silver layer, right? So let's move right in and begin coding these tables straight up, right? So at this point, we're going to create the orders enrich, which is in the silver layer, right? We are at this point to create a silver layer. And in the silver layer, these are the tables that we create, these 4 tables. This is a clean table, as I said. Yeah. So let's begin with that. Go back and then ensure that our serverless is up. Let's create a text and say this is going to be silver layer. Then create another cell. And in the silver layer, first, what we need to do is to, we already know the table, which is the orders table, and we can see there is a now date format negative. So let's clean this data, which would be the cleaned architecture, the clean orders table, right? And first, let's select the fields that we want to see, right? So let's say cleaned. So let's look at the structure and say raw, right? This raw, the raw table, spark.read.table, right? And we know the raw orders table is this. We select this, we give it to that, and now good. We have this variable for the raw table, which is this, right? Which is this orders table. Now we can look at the table if we wish to, but we already know what it is. So let's look at the structure. Let's clean the structure and select the columns that we want, right? So let's create the type that we want to see. So we'll go to raw table dot, let's perform an action on it. Select, so we select what, so which columns do we want to see? So we can import we already imported the if we go back, we already imported this from PySpark, but we can import it again just to ensure, right? This will give us error because we've not yet selected what we want, right? So select f.column. So which columns do we want to see? We want to see, if we go back to the orders table, we have the orders ID. So order ID, right? Order ID, we can take a look at it here. Order ID. We also have f.column. We also have customer ID. We have product. We have category. Just copy and paste. We have quantity. And in quantity, if we go back to the data, in quantity, you can see it's begins. We can choose to leave it that way, or we can choose to make it an integer. We want to change the type, right? We want to change the type and make it an integer or something like that, right? So you can say you cast it. We can cast this as, we can do integer type. So you need to import from PySpark dot types. Yep, I think that is giving us an error. So let's fix that. Let's take a look and ensure that PySpark.sql type PySpark.sql types. Let's see. Yeah, this should be correct, right? Yep. Okay. Yeah, this should give us a correct thing. Yeah, this should work. Okay. PySpark.type. Then we import that. Then we maintain the column name alias as quantity, right? Comma. Then we have unit price. So with this, we're just selecting the columns and then changing their types if we want to. We're just telling their data types, right? We know the quantity was a big int. We're just making it integer, right? Because you cannot have 0.1 quantity, 0.2, 0.3 quantity, right? In this instance, right? So this dot cast, we're casting this as well. If we go to unit price is that compute. If we take a look at unit price over here, unit price can be in decimals, right? So we can cast it as double. Already it's in the double. Let me take a look. Let's take a look at the table. Unit price, it's already in double, so we can choose to leave it that way. There's no need to cast it. We can leave it that way. Then we have the order type, order time, right? Timestamp, the timestamp. So we can say so what we can do is to say that we want to ensure that any timestamp that is showing as now as wrong format, we bring it as now. Any timestamp that is showing here, Where could that be? Any timestamp that is having a wrong format, we can say we want to change it as now, as at this point. We wouldn't want to change, we wouldn't want to work so much about it. We just want to have a simple way to execute it. So try to timestamp. So it's an inbuilt function that you can call, right? Try to timestamp. We have the column order ts, right? Dot alias, maintain the column name order ts, comma. Then we have the status. We just call the status as it is. We have the comma. We have the ingested at, so underscore ingested at date. Then we have the file, the source file, source underscore file, right? So now this is the format that we have. We can run this. This is the format that we have. We can take a look at the data, how it changed this. So you can see quantity have been changed from double from what it was. So if you look at quantity, quantity was big int. Right now we changed it to integer, right? We changed it to integer. So that is it. We have this particular structure, data type, the structure that we want it to look, and we've done a little transformation here, just something small, little transformations in here, right? Now what do we want? We want to ensure that this meets some validity as well. The table that we're creating, it should be cleaned, so we need to create some standardization and ensure that the data that we are pulling into or we are bringing into the silver layer is cleaned as we stated in our structure. This should be a clean order. It should be devoid of any null, devoid of all those negatives and negative sales quantity and all that. So let's create to check the validity or validation should meet our standard that we want. Let's create some parameters, variables, and say that any data that do not meet this, don't bring it into the cleaned order, but those that meet this condition or those that fall within this filter, bring them into the silver cleaned order, right? So we create another variable is valid. So any data that meets this should be pulled into the cleaned order. So what are we going to say? So we're going to say that any data, so function column order id, if order id dot is not null, so we want to look at the order id column. Any column that is not null meets our validity, right? Our validation criteria that we want. So bring that data, comma. What else? And right, you need to meet that. And customer id, if customer id dot is also not null, we want all those orders that have customer id which is not null, right? We take out the comma because it was given an error, because it's an end. All this must be met before the data is valid and clean. And so customer id shouldn't have a null. We don't want data that from the bronze that has any customer id that is null. Okay, and order timestamp dot is not null. We also don't want any order that has timestamp as null. And also we don't want quantity and quantity. We don't want quantity that is, we want quantities that are greater than 0, right? And we want unit price that is greater than 0. We don't want any negative unit price, right? We don't want any negative unit price because there are some instances in the data that there's negative unit price. So we can run this variable and have this ready, right? So all right, we have this ready. Now let's go down and say, now we're going to apply some of this filter on the table that we created, right? We're going to apply the filter on the table that we created, right? So this is a variable that we created, having selecting from this rows or this table, having this. So from all this selection, we're going to apply the validity to look for data within this variable that meets this validation that we just created. So we're going to say this will be a valid table. Now we bring type because we already applied the raw in the type dot. So we're filter out data that meets this valid criteria. So any data that meets this is valid criteria, then store it in this valid variable, right? So we go here in the raw table. We know this is the raw table. We go through it and select these columns and make some transformations in here, right? We make some transformations in here. So this is a new variable that's stored from the raw source. So now we want from this table that variable that we've created, we want to filter out data that meets this criteria and store it as our valid, and that will be our cleaned silver layer, right? So valid this, we can run it, and we have a new valid criteria in here, right? A new variable. Now, so far we've not yet pushed it into a table that we want to call, right? We're just creating the scenarios, we laying down the structure and coding it out to ensure that it meets the standard that we want. Now, what we need to do is to then apply some more transformations, right? There are instances that they are duplicates in the data that we have, though it meets this validation criteria, but they are duplicate. So we want to take out some duplicates from the table, right? With this, you need to use Windows function. You need a Windows function to do this. So we need to import the Windows function from PySpark, right? So of course we can import it from the beginning, but we can bring it down from PySpark .sql.windows import window, right? This way, from PySpark SQL window import window. Great. So now let's write our Windows function. Windows function will just, what we do is we use a row number, right? We are going to count how many times a particular order have occurred based on the order ID. So we look at the ID, we look at the order ID, then we count how many times that ID have occurred in the table. If it is more than 1, that means it's a duplicate. But if it is 1, that is not a duplicate, that's a unique. So with that, we just select the ones that are equal to 1. So we just count, using the ID as a basis. We count how many times that order ID have occurred in the table. Then if it is more than 1, if it is 2, 3 going, it means that's a duplicate. So we take out all the ones that are 2 and above and just stick to ones that are equal to 1. And that means we've taken out every duplicate in it, right? So to do that, let's create another variable, which is dedupe window, right? So dedupe underscore window equal, we're creating another variable. So we call the Windows function window dot, so we partition. How are we partition it by? As I said, we partition by the order ID. So we look at the order ID, then we partition. If an order ID occurs twice, that means the first one will be 1, the next one will be 2. So you partitioning based on the order ID. That's what it simply means. And dot, how are we going to order it by? Order by. So we already know, even if an ID comes twice, you need to know which one comes first, which one comes second. That is when you need to use the you can use the ingested at, or you can use the sales date at, right? So by in this case, we want to use for f dot call f dot column, but we want to use, in this case, we want to use ingested at, right? Ingested at dot, how are we going to order it? So if you look at the date, ingested date, how are we going to order it? Is it descending or ascending order? In this case, we want to say descending because the new ones, newly ingested, should come first, and then the old one should be old, right? So descending this way, right? So now we have a variable that does the partition for us. Now let's apply this variable on the actual table, right? So we have another silver. We create another variable, silver order equal. So we know this is the valid variable that we created, which is a new data frame, which has met our validation criteria that we had here. So we need that table. That's what we use, valid dot. We create a new column with column into bracket. The column name would be underscore row number, comma, function dot row underscore number. That's an internally built function that you can make use of. Dot over, how are we group this? Dedupe this variable. So we count based on this partition. So we count the row number, how many times a particular row based on the order has occurred, right? Now what do we do? Dot, then you filter. What we'll do is we filter based on the row number. As I stated, row number, where row number equal 1. So with this, what we are saying is, if you, after the Windows function has been done, right, you've done the Windows functions, found duplicate, we only need these columns. We only need the one that is equal to 1. That is what I said. It's going to arrange it based on 1, 2, 3, 4. And if a number occurs several times, it will just say count it as incrementally, right? But we only need the column that is equal to 1, right? Now, after that filter is done, we don't need this column to show in our database, right? So we can drop it. Dot drop row underscore row number. Now we may want to add a new column, which would then be like total quantity or line amount, right? Quantity multiplied by unit price. So we may want to add with column. So that was not part of our initial design, which is here, but we can choose to add a new row and say line amount, which will be price times quantity, this way, right? Which will be price times quantity. So this should just be, it can be a float, right? It can be a float which will accept decimals. So we say with column line amount, comma, so we have f, so we can round, f dot round to bracket f dot column We call the column that we want, that's quantity. Quantity multiplied by f dot column unit underscore price, this way. And since we are rounding, we can say it should be to 2 decimal places, right? It should be to 2 decimal places. I think this is giving me error, that's why it's underlining. I think we forgot something here. Yeah, great. So this is what we have now, right? So we took the valid table, then we applied to remove duplicates, and we only selected data that meets this criteria that are not duplicate. Then we dropped the Windows function that we did, and we added a new column to multiply quantity times unit price, and we had this. So now what we'll do is to create the table itself. So we have silver. The name of the table that we have is others enriched, so we can say underscore silver.order. We are writing this to a table dot write dot the mode. In this case, the mode will be overwrite. We will overwrite it. That means anytime you run it, it should go delete everything and replace everything. In this case, right? Overwrite dot save as table into bracket. Now we can call the table name, right? But we can also create a variable that would serve as the table name for us, right? So we have others enriched can be equal to, as we did before, others enriched can be equal to this, right? Can be equal to, so this will be silver, and the table name, sorry, would be others enriched, this way, because this is the table name we want to have, that we want to use. So in the catalog, in this schema, create this table. So we need to call this variable in here, right? So this way, great. So we're done with creating this table. Let's run it to see if we have any error in the process. Then we can debug it. Ideally, if this runs, it should be able to create a table, right, named others enriched in the silver layer of our architecture, right, of the schema that we have, right? So as this is working, this should, yeah, great, it's been created. So if we go back to the table and we look at the silver, we can refresh. We can start the serverless. I think it's not been created. Let's take a look why that is the case. Save as table. Oh, sorry, this should be this way. Great. This should be this way. Great, it's been created now. So we have, great. So we have on others enriched, and let's take a look at the table. Yeah, so you can see we have line amount, which is price times quantity. This is times quantity, and we took out the blanks that we had. Let's take a look at the bronze, and you can see the vast difference between them, right? If you take a look at the bronze, you can see we have some null, we have some wrong data, we have some negatives here. We cleaned everything and made this a standardized table where we have clean data and everything, right? Great. We've been able to achieve by creating this. Now let's create a quarantine orders, right? Quarantine orders. Quarantine orders. So let's create this quarantine order. This quarantine orders as well. We already imported a lot of things, so all we need to do is to create an invalid variable, like how we created is valid, right? So let's create invalid variable, invalid equal. We have this typed in here. We can make use of the same thing, variable, the same variable dot. You filter out, right? We filter out, and then we say, now we're going to use a particular symbol called tilde on your laptop. Tilde, that's like a curly bracket, a curly line, right, on your keyboard. You can bring that. That is how we use to indicate it's not, right? It's not. If it doesn't meet this variable, you see this is valid, so we want to say it's not valid, right? So we just bring tilde, anything that happened on that, so it's valid. The opposite of everything in this variable that we created, opposite of it. That's what we want to move in there, right? Dot with column. So let's create a new column and then say that's what we want to do. Let's go back. A column call underscore quarantine reason. So why are we quarantining this data? Why? Then we say if function, then we use a when clause to say that when customer ID is now, then give us, it means it's missing. We are creating a column to state the reason why this is a quarantine table, right, for each of the line item. And we're creating a criteria that if you fall within that, if a data meets this condition, put them in the column or give this column this description to that line item, right? So we say if call column, which is customer ID dot is now. If your customer ID is now, then we give it what? Missing customer ID. This way, right? Next line, dot when bracket if column dot column, that's order timestamp dot is now. If it's now, then we state that that's unpassable order timestamp. Unpassable simply means it cannot be read, right? Cannot be read. It does not meet the standard that we want. When you create another when function dot column quantity is less or equal to 0. So if it's less or equal to 0, that's when quantity is negative or is 0. Then what do we say? We say non, we call it non, we just say non-positive. We decided you can give it whatever name. All this description, you can put whatever makes sense to you, right? Non-positive quantity dot. If all these are met, aside that, otherwise just call it field validation. I think there's something wrong with this. Let me see. Yeah, no, F. I think I'm missing something. I think there's when's supposed to come here. F dot when. Yeah, F dot when. Great. Think we have this now. So this makes the condition. Then we are going to push this value into a table. So just as we did invalid dot write to the table dot mode. The mode, as we stated, would be override dot save as table. The same way we could create another variable for this as well, which would be, in this case, we have others quarantined enriched, right? So we can call it others quarantined enriched, and then we say others quarant this way, and then call it here. So with this, we're writing this data after it has applied to this table and filtered what it meets. We're writing it into this silver layer and calling it others quarantine in this, right? So this is what we're going to do. Let's run this, and this should create a table for us. Great. Let's go back, refresh. Yeah, we have others quarantined enriched, and we have a few data in it. Yeah, so you can see all this data had a problem. All this data had a problem. Missing customer ID, which is this. Non-positive quantity is true. Unpressable order timestamp, which is now. Yeah, congrats. So we've been able to achieve this as well. Quarantine orders. Now let's create a clean customer table. Clean customer table. Now let's create a new cell, and then we create a variable, right, which would be for cleaning the transformations that we do and everything that we just spoke about. So let's call it silver customer equal, right? Silver customer equal. We have spark dot table dot. We may want to create to make this easier for us. We can create a variable and assign that. So raw customer equals spark dot read dot table. We create this table. So we go back to the table. We take a look at the customer table. This is it. We copy it, we bring it in here and give it the assign this. So now whenever we want to refer to the customer table, we just call this variable, right? So we say raw customer dot select to bracket. So what are we selecting? So as we have the f column, that's the function we want to select customer ID. All right, what else? We'll keep it as it is. Now we want to ensure that we trim the email, no lagging spaces at the beginning, at the end, or any part of the email. So we can do f dot trim bracket f dot column. For which column? Which column are we trimming? We're trimming, you can trim the name first. The name of the customer dot alias, that's we rename it, we give it another name, but we will just maintain the same name, not alias as name, comma f dot lower. So email, at times the email comes with capital numbers, or if you look, capital letters, right, or block letters if you want to put it. So if we take a look at that, at times the email, which is the customer's email, comes in capital letters or block letters, right? We want to take a look at some of them to see if something like that. So whilst it's loading, let's wait a little. Yeah, so you can see there are some lagging spaces in this and mixture of capital and small letters. So we want to clean all that and make sure they meet. So we want to say lagging, so lower. So the trim takes out the closing, open, and anywhere where there's unnecessary space, right? Unnecessary spaces, we take them out. Function dot column. So with this column, we changing every email. If you can see, some are in capital letters, block letters, and some are in small. It's a mixture, and that doesn't look good for our data. So we want to bring all of them to small letters, which makes sense for email. So trim email dot alias, we maintain the name email, right? Then we have function dot, we want to trim again the city. So trim dot f dot column, what do we want to trim? The city, the trim. So we want to maintain the name alias, maintain city, this way. And then what else? We want to ensure that the sign-on date is an actual date. So to date, we're changing everything this way. F dot column sign up date, right? Then we're maintaining that as sign up date. Then we also maintain the ingested at underscore ingested at. Great. So this way. Now we've been able to do all this. I think we're missing something, comma. Yeah, sure. Great. So that fixes it. Now we've been able to do this, and we want to take out also, remove duplicates, count duplicates, look at duplicates. If there are any duplicates, we take them out, right? So we'll do we create a new column with column and name it underscore rn, comma, the function dot row number. It's pretty much the same thing we did in the initial one. Dot over so over window. We already imported the window, so we know window dot partition by. So how are we partitioning it? We are using a customer id to partition it. Then we order by what? We need to order by the ingested date, right? F dot column, which will be underscore ingested date, ingested at. How are we going to order this? We order by descending order, right? As I said, descending will take the most recent date, right? Create that is that. Then we have order by. Let me bring this here. I think we need to do this within this. Yeah. This, yeah, this exactly. All right. Then we have dot the withColumn dot filter. So we are filtering the data. F dot column. We are filtering out RN where row number, the windows we did, right, equal 1. Then what do? We drop that column exactly as we did it before, right? We drop that, and we don't need the. In this case, we maintain the ingested at. We can maintain the ingested at. We can maintain the ingested at in this case. So we can run this. This shouldn't give us an error. Great, it didn't. If it did, then it means we made some mistakes. Now that we've cleaned this, let's push this data into a table, right? Into a new enriched table with the name customers enriched. To do that, the same way we did, we can create a variable, right? We can create another variable, customer enriched. We can go back, get this name, come here. Great, we've created a variable. So now let's push this into a table, this table. Let's put the data. So we say silver.write.mode. The mode we write in this is override dot. So we do the same, save as table. You're saving as this table. Right. Let's run this again. And this should create the table, this table that we have in the silver for us. Great, it's been done. So we can take a look. Yeah, this is good. Let's go back and refresh and see if the table exists in the silver schema. Great, this is it. Customers enriched. Let's take a look at the underlying table that it gave us. Now we can see everything has been cleaned. All data has been cleaned as we wanted. Stream. Yeah. Yep. Great. So this, we've been able to create this table as well. And this is it. We have the final one to create, which is the orders customer enrich. That's, we're joining these two tables. We're joining the orders table, getting the specific customer's detail who made those orders, right? And pushing it into the server. That's our next thing. And this is pretty much straightforward and easy, right? But let's do it. So we have to create the table and then do a join with it, right? So we have server. So we're creating this table now, customers enriched, right? Server orders, order customer, right? Equal, open bracket. So we need to do a join. So if you take a look at, to do a join, now let's go to the bronze. If you take a look at the customers table, there should be something that will link the customer to an order. So we have the customer ID in here, looking at the format C01, C02. You see? Now let's go to the order and see if we have something to link back. Yeah, we have customer ID as well here. Let's take a look at the actual data, the structure of that. C01, C02, C03. Perfect. So we can connect, we can join the order to the customer table using the customer ID. Right. So we can do that using the join. So spark dot table. You can use a variable as well. Normally I prefer using variable, right? So spark dot table, you can do so we're joining it from the server level. So we have spark dot orders enriched and customer enriched, right? So orders enriched spark dot read dot table, we have customer reach equals spark dot read dot table. This way, then you grab the enriched customer table, go back, do it this way. Great. Now let's do a join, right? So we have the order table, right? This way, and then dot join bracket, we're joining it to the customer table, join it to this, comma, using what? Using the customer ID. Which type of join? We are doing a left join. Then if you do a join, what result should we bring? We should bring everything. We can do select bracket open customer. You can do order enrich dot star. In fact, what we can do is you can do it this way, dot star, comma. Then we need the customer name dot name, customer dot email. Then we need the customer.city. So that's what we need. We can do that, and then let's run it and see if we have some error. We can debug. No error, so everything is good. Then now we can push this into a table. So we have silver order dot write dot mode. The mode would be overwrite dot save as table, and in which table you can save it as we have this is the name we want to use. So in this case, I don't want to use a variable. I can just call the table, then change the name to this and say this is what we want to create. So let's run it. Okay, given input ingested dot at. Cannot resolve dot given that the input. Okay, so what we can do is it's giving us an error. It's giving us an error. What we can do is this. We can just bring this down. I wanted to use star so that it populates everything that is in there, but from the others enriched, right? From the others enriched, what we can do is just to call them single, one after the other, right? So we can go to the others enriched table and just call the other ID this way. Then we have the other ID. I'm just trying to reproduce so that I can get. We have this customer ID, product, catalog, quantity, unit price, in that order. So that's what I want. This is what I wanted. Maybe another one for ingested that. I'm not interested in the source. Line amounts. So we can push this, right? And then this should create a table enriched orders, right? So this has all this. Let's take a look at the actual table. It should be in the silver. Great. This is it. Orders enriched, creating this particular table. So if we go back and we take a look at the data. Great. So we have this clean table and we are able to trace which customers made this order and their city, right? And that's it. Great. So we've been able to achieve the silver layer by creating all these 4 tables that we have. The next stage in the architecture is to have the gold, which is the final stage for the whole architecture. Then the BI team can make you rely using the gold layer to do the analysis, and the ML engineer can use that to do their projections and AI stuff, right? So we've been able to achieve bronze, silver. Now we are in the gold to create that. So the same way we need to create heading and say gold layer. Right. Kudos if you've been able to watch the video to this stage. We are almost at the end of it, and then you'll be able to have a full project that you can add to your GitHub, right? You could just save that to have understanding into the logic, the principles that we applied here. And as I stated, the link to the resources, that's the code base, this design and everything resource used is in the comment section. Check that, click the link, go and download the link, the resource, the code base, every data, everything we did here is in the resource section in the description of this video. When you are done, you can write a post about it on LinkedIn and all that, and how you achieve that. You can post it and then tell other people, let other people know about this channel, share it, like, subscribe, and let's learn together, right? And this is the PySpark version of it. There would be a SQL version of it where everything is coded in SQL, right? And then we achieve the same result. Let's go back to the gold layer. Now let's create another design and call this gold, right? So this is the architecture we're building. Always we want to have a visual representation of what we're building before we move into the coding aspect, right? If you go that way, you understand the process, you understand the logics behind it, and it helps you break everything down in a procedural way or in a well structured way. That is how come we're using this method, right? And it's very good for beginners. That is why this video is very good for beginners. Share it and invite others as well. So in this case, we're going to create a table that only looks at completed tasks or completed orders, right? And the first table that we're going to create would be for looking at the daily sales, the total daily sales for that has happened, right? The orders that are happening in a specific day. So let's go grab the one table here. Let's say this and bring it here. And then we grab the heading, bring it also here. And with this, maybe we give it a name, gold. So this will look at the completed daily sales, right? Daily sales. And aggregate, like we're looking at an aggregation table. We could also even bring the whole original how do you call the silver tables that we created. We could push them back, bring them into the gold, and then from there we can build our aggregated tables. But in this scenario, we just want to create an aggregation table, which will help the analyst and other team members to make use of. So we're going to look at orders. We're going to look at daily sales. So this will be an aggregated table, right? Gold daily sales, right? This will be an aggregated table which would comprise of the orders timestamp, which we will change the name though. When we are coding, we'll change the name. Then we have the distinct orders ID. Then we also have the sum, right? We will look at the aggregate, the sum of total quantity. You look at, right, unit sales, units sold. Then we look at the line amount, which will be a total sale, right? So this should be timestamp or date. We can make it timestamp or date, and this should be an integer. Unit sold should be integer, and this should be float. We do not need a subsequent field, so we can delete the rows, the remaining rows. So yeah, so something like this. So this for daily sales. We can look at product as well, products performance, right? You can have another one, product. Look at the performance of the sales based on product level, right? So product performance, right? You can have this table here this way. So we have gold, product, performance. These are going to be aggregated tables like sums and all that. So we have the line item, we have the product, we have its category. Of course, this will be string. Then we have the line amount, we have the quantity as well, which will be the unit sold, and then we have the line amount, which will be a summation of everything, or count these things. And then we can add another one, which will be for order ID, which will be, I think the order ID in this case they were string or something. Yeah, I think so. Yeah. And then we have a last one to look at, the customer. Let's move this here a little. So we have another one, final one, which is the customer value. How much customer value? How much value are we deriving from the customers over time, right? Which will be customer ID, name, city. We have the line, the order, and the final one, order timestamp, which will be a time stamp. Yeah, so this is what we're going to create. These are the tables that we create in a gold layer. From this, then your AI engineer or business analyst can build dashboards on top of this and then represent it and explain to management, right? Yeah, so let's delve right in to build this. So this is the gold layer. Now let's create a new cell. We are going to start with the daily sales. First, let's ensure that we have our function running. We can call back this, right? We can call back this and rerunning. And it shows that it missed. And now let's create our table. So first, we're only going to base these tables on completed orders, right? Completed orders. So let's look at completed orders. Let's create a variable for completed orders. So spark.read.table. You're going to look at only completed orders. So let's go to silver. Let's start the serverless. It's already starting. So we need completed orders. Completed orders table. Right. Let's take a look at this table. This is the cleaned table. I think so. Yep. So we pick this table and we created a variable. Now let's create this table, completed orders, as we should, right? Now we have completed, that which is this table we already have, completed dot group by, we are grouping by columns, we are grouping by, so let's ensure to date, then we have by which column. Let's take a look. Others timestamp, so we're using others timestamp. Order, what's the column? Order underscore ts. We're ensuring that we're grouping by this date, so all others that have group others these dates, right? So we can change the name if you want to. So let's say we want to change it to alias, we want to change the column name, right, and name it order date, right? Dot, let's aggregate, we are aggregating f dot column, let's f dot round into bracket f dot sum. So we're summing, which column are we summing? Line amount. So we're summing all the values that are showing line amount, all the sales that have happened on a specific date, right? On a specific order date. So with that line amount, then we're running it to 2 decimal places, and we want to change this to alias dot name it what, we just want to name it revenue, comma f dot count. So we want to have another column which will count, we should count distinct, the unique order id, the unique order id, right? Then we may want to change the name to orders, right? Then we want to also sum quantity dot alias unit sold, right? So we have that. Then what do? We want to order this data by order date, what we have here, we want to order by that. Now we want to write to the table that we want. You can do all that together. Dot write dot mode overwrite dot save as table. In this case, we want to save the table into gold. So we have bakery, we want to save it into gold. The table name that we have is gold daily. So gold daily, this way. If we run this, we expect this table to be created in a gold layer, right? This will represent the first table that we have here. So let's run this. Yeah, so this is running. What it does is to create the gold table daily sales, gold daily sales in the gold layer, right? You would create that table in there, which you can make your. So it's still running, performing its aggregations. It's done. So we should find this table in the gold layer. If we go back, we refresh. Great. We've been able to create this table in this gold layer. And if we take a look at the data, this is what we have. So we know on these days, this is the total revenue we made. How many orders occurred on these dates? This is it. How many units were sold? This is it. Right? Great. So this an aggregation and overview, and then we can make use of this for visualization, right? Great. So we're going to create the next table is to create the product performance table, which is pretty much almost the same. So let's create it as well. This will also pick from the completed dot. We also group by, we'll group by product, let's say others enriched. Let's take a look at others enriched. Yeah, it's the others enriched table. So that's great. We group by product and category, right? Then we apply our aggregate. We apply our aggregate as well on it. And then to apply the aggregate, we're going to do f dot round to brackets f dot sum. We sum the line amount that we have, right? The line amount that we have in the table. Is that line amount? Yeah, this line amount. Yeah. Great. We round to 2 decimal places. Maybe we rename it to alias. We rename the column to revenue, just as we did. Then we have the next one is f dot sum quantity. We sum the quantity, then we rename the quantity as unit sold, right? Comma. We create a new column, also count distinct order id dot alias into bracket orders, right? So we have that dot, we order by, and we know this time around we're just going to order by the revenue by in descending order dot descending order by the revenue, or you can do it order by revenue dot descending, right? It will also work. Order by f dot call revenue dot descending, open and close, something like this. Call revenue dot descending. This way, this also works. Same as this will also work, right? Then we have dots. Now we want to write into a table that we run. Write dot mode bracket override dot save as table to bracket. So we want to save into a gold layer, but this time around the table name will change to this gold product performance, this way. So if we run this, we should create that table in the gold layer. This is done. Let's go and take a look. This is it. It should have some data. Perfect. So this is what we have in here. So this is done as well. So we've been able to create this as well. The final one is the customer value, right? So let's create that. So this is, let's just rename this so that you can tell. And then this also creates the good daily sales table. Now we in creating the final table, which is the good customer value table, right? Good customer value table. And the same thing we'll do, we're going to use the completed variable that we created initially, this same table, right? Dot group by. So we grouping by this time around, we grouping by customer ID, comma, name, because we want to have these columns as part of it, as part of the aggregation after it's done. The city dot aggregate, open and close bracket, your functions, round. What do we round? We round the sum of which column? Line amount. How many decimal places? To 2 decimal places. Then we name it alias. We give it a new name, right? The customer lifetime value. So we can have, we didn't add that here, but we could add it, customer lifetime value, which is another column we can do. So we have the next one is count distinct. So we're counting how many distinct orders fall in this. Order ID dot alias as what orders. Right? Yeah. Then we have the next one, which is we want to find the maximum order date, right? So f dot to date bracket order timestamp dot alias. We name it as what? The last order date. Why did this keep underlining and giving me a bag? Okay, so let's order by, just as we did, f dot descending order. We are by the lifetime value, right? Then we write to a table dot mode. That would be an override dot save as table. Then with this, we want to call this same structure, but this time around the table name will be good customer value. We run this and we see. name cannot be resolved. Let's check the table. If we have a column called name, let's see. I think the right thing we need to use is this particular enriched. So we're going to change the completed equal completed new equal this, and then we change this to underscore completed new. Let's run this and let's see. Group by okay, it's saying string attribute has no so spark we spark dot read dot table. Yeah, we needed to call it as a table. We were calling it as a variable, so this should work. Bakery, I think we left out. Yeah, so it worked now. Let's refresh and see. Customer value. Great. Now we have these values. All right. So you see how we were able to debug this. That's how you meet it. Whilst you code, you meet errors, debug. You need to debug it. So fantastic. If you've been able to read this side, that's great. You are one step away from becoming an expert very soon. So great. This tutorial is to help you gain understanding into how the structures, how we architect some of these data engineering pipelines and all that. This is a fundamental that will help you, give you understanding and give you the logics that you need to begin your career in data engineering. Great. So if we go back to our diagram, perfect. We've been able to build all the layers in the architecture that we have here in this bakery architecture that we designed for beginner level. It's been great having you to this level, to this stage. Like, subscribe, share to your family, share to friends who want to learn, and those who want to become data engineer as well. Those who are pivoting from product analyst, data analyst to become data engineer. It's been great having you, and it's been your favorite data engineer, Henry. See you on my next video, which would be a SQL version, full SQL version of this same video, and you'll be able to learn how to write the same thing in SQL as well. Great. You can tag me on when you write your post about how you were able to build this on LinkedIn, Facebook, Twitter, everywhere. Great, or X, I mean. Yeah. See you next time. Bye-bye.